Hi friends, welcome back to Connect with Civil. Concrete is the most commonly used construction material and it's a solid mass made by the use of a cementing medium. The ingredients generally comprise of cement, fine aggregate or sand, coarse aggregate or gravel and water. This video explains how do we calculate the quantity of dry ingredients, that is cement, sand and coarse aggregate required for concrete. Suppose we have to find the quantity of ingredients required for 1 meter cube of M20 concrete. So here we have two inputs given. One is volume of the concrete and another is the grade of concrete. Here the volume mentioned is the wet volume. Wet volume means the volume of the concrete when we mix all the dry ingredients and water together. So from this wet volume we have to find out the dry volume. Okay, now what is dry volume? Suppose we took all the dry ingredients separately in separate boxes, measured their volumes and added all the volumes together. This cumulative volume is termed as dry volume. When we mix the materials of different sizes and shapes together, there will be gaps created in between the larger particles and the finer particles may occupy these voids between the larger particles. So, for these finer particles, there won't be a requirement of much additional space. So, cumulative volume of the ingredients taken separately will be greater than the volume of the mixed ingredients. Means dry volume will be greater than the wet volume. In case of concrete, it's been observed that the dry volume is almost 52 to 57% greater than the wet volume. So in this calculation I am considering 54% increase. So let's calculate the dry volume for this wet volume of 1 meter cube. That will be equal to 1 meter cube into 1.54. Before that, how are we getting this 1.54? Dry volume is equal to wet volume plus 54 plus 54% of wet volume. Wet volume we can take it as common outside. So wet volume into 1 plus 54% we can write it as 54 by 100, that is 0.54. That's how we are getting this 1.54. So we will get a dry volume of 1.54 meter cube. Our remaining calculation will be based on this dry volume. Now our next input is the grade of concrete, that is M20. Its mixed proportion is 1:1.5:3. Here 1 refers to 1 part cement and 1.5 means 1.5 parts sand and 3 means 3 parts coarse aggregate. Adding all this we will get 5.5 parts. So in 1.54 meter cube dry volume of concrete, 5.5 parts of dry ingredients are there, in which 1 part is cement, 1.5 parts are sand and 3 parts are coarse aggregate. Now let's see how to calculate the volume of each ingredient. First, volume of cement. So volume of cement will be equal to 1. We know there is 1 part of cement among 5.5 parts of dry ingredients to get a volume of 1.54 meter cube of concrete. So that will be equal to 0.28 meter cube. Okay. Next is the volume of sand. We have sand 1.5 parts. So that will be equal to 1.5 divided by 5.5 into 1.54, which we will get a value of 0.42 meter cube. Since the cement is 1 part and sand is 1.5 parts, we can just multiply the volume of cement with 1.5 also. That also will give you the same answer. Now next is the volume of coarse aggregate. So that will be equal to, there are 3 parts in 5.5 parts into 1.54 will give you a volume of 0.84 cubic meter or 0.84 meter cube, or we can just multiply 0.28 with 3, that will give you the same answer. So now we got the volume of all the dry ingredients. Now if we add all these volumes, we should get the total dry volume of 1.54 meter cube. So we are getting 1.54 meter cube. That means our calculation is correct. First part of our calculation is finished now. We got the volume of all the dry ingredients in cubic meter. Now if we go for actual work, you will be purchasing the material in different units. That is, cement we will be purchasing in bags, sand and coarse aggregate will be in cubic feet. So our work will be finished only when we express all these quantities in their correct units. So let's see how to do that. One bag of cement weighs 50 kg. So first let's calculate the weight of the cement from the calculated volume. Weight of cement is equal to volume into density. So volume what we have calculated is 0.28 meter cube into density of cement is 1440 kg per meter cube. On doing this calculation, we will get the weight of cement as 403.20 kg. So number of cement bags will be equal to 403.20 divided by 50, because one bag contains 50 kg. So thus we will get 8 bags. Next is sand. Sand, we have the quantity in cubic meter. We have to express it in cubic feet. So just we have to convert to the unit. So volume of sand is equal to 0.42 meter cube. That is 0.42 into 35.31. That is the conversion factor for cubic meter to cubic feet. So we will get 14.83 cubic feet. Coming to the coarse aggregate, here also we have the quantity in cubic meter. We have to convert it into cubic feet. So volume of 0.84 cubic meter into 35.31, that will give you 29.66 cubic feet. Now we have expressed all the quantities in their proper unit. Let's tabulate all these values. So cement quantity is 0.28 meter cube and sand is 0.42 meter cube, coarse aggregate is 0.84 meter cube. So if we express it into proper units, cement is 8 bags, sand is 14.83 cubic feet and coarse aggregate is 29.66 cubic feet. So these are the quantity required for 1 meter cube of M20 concrete. Now if we have more volume, that is 600 meter cube of M20 concrete, how do we calculate the quantities? There are two ways to do this. First thing is, if you remember all these quantities for 1 meter cube of concrete, you can just multiply that with 600 cubic meter or whatever may be the volume, you can multiply directly with these constants. Like cement is equal to 600 into 8, sand is equal to 14.83 into 600, coarse aggregate is 29.66 into 600. Or otherwise you can do the same calculation what we have done for 1 cubic meter, replacing 1 with 600, that is for cement 600 into 1.54 will give you the dry volume. So in that 1 part of cement divided by 5.5 parts of concrete, that will give you the volume of cement. Similarly 600 into 1.54 into 1.5 parts of sand divided by 5.5 parts of dry ingredients. This will give you the volume for sand, and coarse aggregate 600 into 1.54 into 3 divided by 5.5 parts. Both of these calculations will give us the same value. Now try this. Find the cement, sand and aggregate quantity required for 100 cubic meter of M15 grade concrete.